All right. Chemistry review time. Okay. All right. So this is the chapter 9 practice test answer key / how do I do it? Calculate the number of grams per mole of Ki. Well, if we look at K is potassium, and potassium is 39.10 grams per mole. Where do I get that information? On the test, there's going to be a mini periodic chart. Now, I is short for iodine. That's 125.00 grams per mole. Okay? And with that, ladies and gentlemen, we just add those up together. So we're going to have 1 mole of KCl, Ki, 1 mole of K, which is 39.1, 1 mole of I, which is 125. When we add those bad boys up, we come out with 164.10 grams per mole. And that, ladies and gentlemen, is the answer to the first question. They shouldn't be too bad. Let's move on. Calculate the mass of 2.50 moles of CaSO4. Well, the first thing we need to do is find out what is our thing. Now, calcium is 40.08 grams per mole. We know that sulfur is 32.07 grams per mole. And we have 4 oxygens, so we can break it down like this. Okay? Each oxygen is 16 grams per mole. Where are we getting this? Well, we're getting it from our periodic chart. Now, some people would say, well, Mr. Canu, do I have to write all those 16s out? No, I'm just showing you step by step, okay, the way it's going to work. And you're going to walk away with 136.15 grams per mole of CaSO4. But is that the final answer? Well, no, because I need the mass, right? So, great. Now I know how much 1 mole weighs. If I am going from moles to grams, I need to multiply. What am I multiplying by? Well, according to the problem, I have 2.5. So 2.50 moles multiplied by 136.15 grams per mole of CaSO4. I'm going to grab my calculator here and say, all right, 2.5 times 136.15, and I walk away with, here we go, watch it, 340.375 grams. Now we can go ahead and round it to 340.38 grams. I am okay with this. Okay? And that's it. If you're still kind of struggling with this, remember there are other videos that you can catch on there. Remember, hit that bell to be notified by the notification squad. All right, here we go. Here's another one. Now this one is looking at moles of reactant to moles of product. Chlorine gas may be easily prepared in the laboratory according to the reaction below. 2 KMnO4 potassium permanganate plus 16 HCl. That is a lot of acid. Woo! Gets us 2 manganese 2 chloride plus 5 chlorine gases plus 8 waters plus 2 potassium chlorides. That's a salt solution. Okay? How many moles of HCl is needed to make 3 moles of Cl2 gas? Okay. Well, they're telling us that if I want to make 3 moles of this, of Cl2 gas, and I need HCl. How many moles of this do I need? You'd say, but wait, you worked on it where you gave a number here, you mentioned excess, and how much we were supposed to find on this. Okay, you're right, but the way we solved the problem, it's the same idea, okay? So let's take a look at this. First off, if you notice, nothing has been written in excess. Nothing else has been mentioned. So guess what? See this? Goes away, goes away, goes away, and goes away. Now we're only left with those two. So I'm going to look at what are my equations here. I've got 16 HCl, that's a ratio, to 5 Cl2. So that's our ratio, 16 HCl to 5 Cl2. It doesn't matter which one you put on the top or the bottom, as long as you do the same thing on the other side. Okay? So in this case here, I'm looking at X moles of HCl and over 3 moles of Cl2. Now notice I didn't put a 5 here, I didn't put a 16 here. You don't need to, because this is just the ratio, okay? When you look at something like this, it's like, look, I need 4 wheels to 1 car. If I have 16 wheels, so I have 4 wheels to 1 car, that's the analogy. If I have 16 wheels, how many cars am I going to have? Oh, okay, well 4 wheels to 1 car, we got 16 wheels, that gives us 4 cars. Right, this is the exact same idea. It's 16 HCl's to make 5 Cl2s. I have 3 moles of Cl2, how many moles of HCl am I going to need? Now that, ladies and gentlemen, is when you use the cross multiply and divide. And that's what we're going to do right here. So we're going to go ahead and we're going to do 16 times 3, and that is going to be equal. This is where we're going to cross multiply and divide like this. Okay, so we will have 5 times x. Okay, so working it out, working this out, we have got 48 equals 5x. So looking at it, when we divide it out, x will equal 9.6 moles when you divide it out. 48 divided by 5, because 5 times 9 is 45. You have a leftover of 3. 5 times 0.6 is 3, because 5 times 6 is 30. Okay? So that tells me I need 9.6 moles of HCl. Now I'm going to go ahead and put this at the 50% so you can see exactly the whole problem in its entirety. So pause and take a look at that. Okay? Now I'm going to go back and I'm going to put this, and let's move on. Okay, so what is the composition of DDT, formerly used as an insect in the United States, having the formula CHO? In real life, DDT is not CHO, it's something else. Okay, it's a bigger molecule. But for here, we're just using CHO. Now, what do we mean by percent composition? Well, we're looking by mass, and remember the idea about percent is equal to the part over the whole times 100. Okay? Okay. So, looking at that, we have a formula of CHO. So they're asking us, what's the percent of C, what's the percent of H, and what's the percent of O? That's what they mean. That's what they're talking about. Okay? So what's the part and what's the whole? Well, the whole has to be the CHO. Okay? That has to be the whole, folks. start, let's just look at the carbon. The carbon, in this case, is the part. Okay? That's a very important idea. Well, how do we know about the whole? Well, this is when we add those up. We know that carbon is 12.01, that's our carbon, 1.01 for our hydrogen, 16.00 for our oxygen. So we got those. Let's go and add them up. This is a 0, not a 9. So I got 0.02. 2 and 1 is 3, 3 and 6 is 9, 29.02 grams per mole of CHO. Okay? That's what we have. So now we have this, ladies and gentlemen, is the whole. That's the whole by mass. That's what we're looking at. Now we're going to start looking at the parts. So let's start with the carbon, because it's the first part here. So for the carbon, we know that the carbon is going to equal 12.01 over 29.02. Now remember, this is the part, this is the whole. We're going to multiply this by 100, and that's going to equal a big whopping 41.39% carbon. That tells me that in that CHO, about not quite 42% is based off of the carbon. That's it. Oh, okay. Well, how about the H? We're going to do the same thing with the H. We're going to take the part over the whole. So here's our H, and that's going to equal 1.01, which again, that's not much, right? 29.02, and if you're wondering, wow, how am I getting these numbers like rapido, rapido, rapido? Remember, these numbers come from the periodic chart, okay? And I already pre-worked this because it'd be kind of hard to pull this in under 20 minutes as I'm working with you guys and punching in the calculator. Okay, so this is it. It's going to be 3.48% hydrogen. Okay, so that's what we have there. So we looked at the carbon, we looked at the hydrogen, now we can look at the oxygen. Now, there's two ways you can do the oxygen. I'm still going to go work this way, but you could add these two up and subtract from 100, and that will give you the amount for the oxygen. But I'm going to work it, okay, I'm going to work it like I've done the others. So oxygen is equal to 16.00 over 29.02 multiplied by 100, and that's going to equal 55.13%. So that's what it looks like, ladies and gentlemen. So now we figured out what our things are, so I'm going to go and put this back. So here is the entire thing. Pause. And then examine it. Give you guys a little bit of time there. Pause and examine. All right, now I'm going to move on. I have to move on because I want to make sure this is done. Okay, now what is the percent composition of salt substitute KCl? This is exactly like the previous problem. Okay? Now, what do I know? I know that K and Cl is 35.45 grams per mole because I get that from my periodic chart. Okay. The K itself is a big whopping 39.10 grams per mole. Okay. Now, if we were to go and add those up, remember, guys, this is going to be the whole, the complete, the whole of KCl. That's the key. And that's going to be 74.55 grams per mole. Now, for the final answer, are you going to have grams per mole? No. They're going to cancel each other out. This is a percent that we're looking for. Okay? So we're going to look at that. Now we can turn around and say, okay, what is the percent of the potassium? Well, remember, again, it's the part over the whole. What's the part? 39.10, okay, over 74.55. Notice I didn't bother with the grams per mole. It's done. Those units cancel each other out. But I want to point out, this is the part, and this is the whole. And remember, we are going to multiply this times 100 to get our percent. Okay? So for that, the potassium, oops. So for that, guys, let's see, I'll do a real fast thing here. How much time do I actually have left here? Okay, I got to wind down fast. Okay, so 39.1 divided by 74.55 equals, and I have 52.45%. So I have 52.45% potassium. Now, if I want to go and look at the chlorine, I'm going to say 100 minus 52.45%. I can do that, right? Okay, so 100 minus 52.45 equals, and I have 47.55. What does that mean? That means the percent oxygen is 47.55% oxygen. This is our total thing here, and I'm going to give you guys a quick moment to take a look at this, because I've got to wind this one down. I'm running out of time here, okay? These questions, excess reactant. You have more than enough to do the reaction. Actual yield means what you physically produced in the lab. Theoretical means what you calculated on paper. And then our last thing, you are in the lab running a chemical reaction, okay? And you're actually produced 4 grams of NaOH. What would you be the percent yield that the reaction could theoretically produce? 8 grams. Okay, this is simple. Percent yield is equal to the actual yield over the theoretical yield times 100. In this case, our actual, because we said actually, goes with the 4, so it's going to be 4 over 8. Okay, that's what we said. Theoretically, producing the 8, 4 over 8 times 100. Guys, that gives us 50%, which is really, 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 really lousy. Okay, and I'm stopping right about here. Okay, should be able to see this. So that's the whole thing. Actual yield is what you physically get in the lab. Theoretical is what you calculate on paper. So we combine. Yes, I will give you guys the formula. Okay, I gotta sign off. Okay? I hope this helps you guys out. Take care and God bless.